Hello all, I hope your holidays or break is going well. This is exercise 1J, so you should have done this in the last class at the end of term, but hey, we all know how well we actually work when it's a Friday, last day of term. So I thought I'd go over this for you all quickly again. So exercise 1J, it's simultaneous equations and we're solving via substitution. Okay? We'll start with some couple easy ones, and the thing here to note is that we are, let me get my pen, we are solving. If the pen will work, come on. There we go. Okay, so we are solving by substitution. So solving means we're finding our unknown value. So in this case, we have y equals 2x minus 3, where x is equal to 6. Okay, so this is pretty easy. We set y equals 2. We substitute in our 6 for x minus 3. Y is equal to 12 minus 3. Y is equal to 8. Next problem. Okay, this time we're substituting in y is equal to 8. So this is 8 is coming in for y. So we have to do a little bit more work. So y equals to 3x on 5 plus 2. So we need to solve this for our unknown, which is x in this case. So we're going to get 6 is equal to 3x on 5. So 5 times 6 gives us 30 is equal to 3x. I'm just going to come up over here. So we get x is equal to 30 on 3. So x is equal to 10. So those two are pretty easy. Those ones we've seen before. This one's a little bit more involved. 2y plus 3x is equal to 1, where y is equal to x plus 3. Okay, so we're going to substitute this in for y because we have y by itself, so that makes it easier. So we have 2x plus 3 plus 3x is equal to 1. We're going to expand the brackets. Plus 6 plus 3x is equal to 1. Collect like terms, so 5x plus 6 is equal to 1. 5x is equal to negative 5. So x is equal to negative 5 on 5, which is neg 1. All done. Now the next slide, this is just looking at an more full worked solution of what's exactly going on in part C here. So we start with 2y plus 3x is equal to 1, and y equals x plus 3. Now if we're being rigorous, which we always want to be in our mathematics, we want to be rigorous, we actually define each function, okay, or each equation I should say. So we're going to call this equation 1 and we're going to call this equation 2, and we road map, okay, we signpost. We're letting whoever's reading our work know what we're actually doing. So we're substituting 2 into 3. So the shorthand for this is sub 2 into 1. Okay? That's what we did, so you can write that. Okay? And then the working as follows. Okay. Big part here, and I didn't even think about it here, okay, we solved for x, we still don't actually know what y is. Okay. So that's what this bit here is, okay. We have this bit, okay. We might actually call this 3, it's not on the notes, but we'll call this 3, and we're going to choose y equals x plus 3 to sub it into because it's easier. So in this case, the signpost here, our roadmap, is saying sub x equals negative 1 into 2. We could also just say sub 3 to 2. Put it in, we solve, and we have our solution. So this big key here, okay, is just adding in some terminology, okay, some process to actually explain so we're clear. And we'll use this a lot more too when we solve via simultaneous equations. Okay, so it's a good habit to be in now. So we'll try one more and we'll use all of our signing and notation. So we have y equals 5x minus 4 and y equals 3x plus 6. Use the method of substitution. So I'm going to call this 1 and I'm going to call this 2 and I'm going to go 2 into 1. Okay, so I'm going to put this here in as y. Okay. Therefore, we can say 3x plus 6 is equal to 5x minus 4. Now it's a matter of getting like terms. I'm going to move 3x over this side because it's smaller, and that'll work out quite nicely. So we're going to get 6 equals 8. Oh no, that's going to be 2x minus 4. So we're going to get 10 equals to 2x, and we get 10 on 2 is equal to x, so x is equal to 5. Now, solve. So it means we need to find the unknowns. We found x. Have we finished though? No, we haven't, because we still don't actually know what y is. I'm going to call this 3 now. I'm going to say sub 3 into, and we can choose either one, whichever one you like. I'll probably just pick 2. Coefficient smaller. So we get y is equal to 3, putting in our 5 plus 6y is equal to 15 plus 6y is equal to 21. And if we substituted 5 into this one, we should get the same answer. So 5 times 5 is 25, take away the 4, gives us 21 again. So that works. So tick, tick. Lovely. Okay. So this example here is actually constructing simultaneous equations. So this is a bit of an application problem. The two telephone companies have different rates. Telephone company A charges $40 up front and then $30 per month. Telephone company B charges $0 up front and then $35 per month. Construct an equation for A, construct an equation for company B. Whenever we have any of these problems and we aren't given variables, okay, we aren't given X or M or A or whatever they are, okay, we need to define them. Okay, you will lose marks if you don't define variables because we need to be rigorous. Okay, we need to be rigorous. That's why we define things. Okay, so this one, I'm going to be let X equal number of months. So for this one, company A, they get $40 up front, okay, and we might do C equals cost. So C is equal to 40 and then plus 30 times by however many months, so X. Okay. Cost for the company of B is equal to 0 plus 35x, or we can just say 35x. Okay, so I have to find my variables. Use the method of substitution to find the number of months required for the two telephone companies to cost the same amount and state this total cost. Okay, so we want to state the total cost as well as find the time. So in this case, cost for company A is going to equal a cost for company B. So we let 40 plus 30x equal to 35x. So we get 40 equal, and we're just going to solve for x, subtract that, so I get 5x. So I get x is equal to 40 on 5 is equal to 8. Okay, and 8 what? We go back to our original definition. X is number of months, so x equals 8 months it takes. Are we done yet? No, we need to state the total cost when this occurs. So we can substitute 8 into either one. Okay. So let x equal to 8, it follows on that. Let's do cost A, just to be rigorous, is equal to 40 plus 30 times by 8 is equal to 40 plus, okay, 3/8 are 24, so this is 240, so the cost is equal to $280. $280. Okay. Now the remainder of slides are using your CAS calculators to do this. I'll leave this for now for you to try by yourself. Okay, just follow through the instructions. The big thing here people forget is we put in our two equations or relations. Okay, you need to put on the end here the x and the y, the variables you actually want to solve for. So you place your equations, and then the solve brackets needs two parts. The first bit is your equations, and then at the end you need the variables you actually want to solve for. So don't forget that. And there's two problems for you to try. And then you can also do this graphically. Okay, all of this work we did is symbolic or algebraic, but you can also do it graphically, and we could have before, but we did symbolically. So this we put in our two equations and then solve. Okay. Now sometimes though, and if we go back to, that's in the form of y equals. Okay. Here, this part C. Okay. We don't have this first equation in the form of y equals. Now we could rearrange it, but sometimes that's hard. If you got squares, then you get into plus or minus issues. So when it's in this form, it's called a relation, not a function, because it's not y equals. So your CAS can actually do that for you. You don't have to do the rearrangement. You just need to plot it as a relation. So these ones we plotted as functions. You'll see it's a f of 1 and f of 2. That's f of function. Okay. The big thing with this is though your calculator needs to be running version 4 point something something. So if you don't have that, this relation in the menu won't appear. So if you don't see that relation option, that's why. So put them in both as usual, okay, two of them, and then you use the analyze graph intersection to find the intersection point, and that'll be your answer. Okay. So there's two for you to solve graphically. And that's it for exercise 1J. So just a quick recap, exercise 1J is just solving simultaneous equations using substitution. Okay. And the big thing that may be new for you is that we just label, okay, and signpost what we're doing. We call our first equation, equation 1, second equation, equation 2, and then describe what we're doing. We're subbing 2 into 1. Okay, that's it.